I have Dr. Lew Lim from the Vie-LED company with us. Dr. Lew, welcome to the show.
Hi, Lisa. Thank you for inviting me to speak with you.
You've developed, so you have a company called vLight. So everyone, we're going to, put the links in the show notes to the devices that vLight has and all the publications and all the clinical studies around these incredible devices. And for those watching on the video channel here, these are two of the devices that I've had for a number of years. And Dr. Lew, you've got the most advanced one there. I've got the intranasal. Wow, that's a serious piece of kit. The neuro.
Yeah, it goes. There's one just like yours. It goes to the nose.
Intranasal. Yep.
That goes to the brain. Right.
Brilliant. So for those watching on video, you can see Dr. Lew has the neuro, which is one of the big transcranial photobiomodulation devices, and the ones that I've got here, I've got a 655 prime, it's an intranasal, and another one with the infrared wavelength of 810, and I use those both pretty much every day to every second day for 20 minutes. And look how good my brain's going. So can you explain why intranasal? So we have to get the light on the inside of the body in order for this to work. Now, it's pretty hard to get light through we know about vitamin D synthesis when we're in the sun and what an avalanche of things that causes in the body, good things. Can you explain why intranasal, and are there other methods to get it into the body?
Yeah, there is, we got this inventor discovered actually about 15 years ago now, actually quite a long time. And so when we got it working, because this whole field of photobiomodulation in the 80s got into, a stage where the Russians started to introduce intravenous blood irradiation with red and infrared light. Now the theory is you put it there instead of on your skin and you provide more power, this gets into your blood circulation directly. Mm-hmm. And what they found was it actually helps with a number of things. The circulation improves better. The users are recovering more quickly from. It seems to help with preventing heart failures and helping to recover. Wow. Then it led to studies of diabetes and finding users are getting marker profile from your annual examination,
your checkups,
medical exam. Now then it wasn't really fully understood for a long time, but they know that the effect is systemic. But quite a lot of work was done later. Researchers in Israel were finding that when they direct light in animal study to the femur, the thigh bone, of the rodents.
Yep.
And they had a scarred heart tissue from simulated heart attack, or from simulated brain injury, or even Alzheimer's disease. They found that the recovery is better, and they can see the improvement in the markers as well.
Wow!
And not too long ago, I think a few years ago, the researchers in Australia, particularly at the University of Sydney, was trying to understand, because they were doing studies in Parkinson's in animals. And they found a similar experiment, mice or rats that were bred with transgenic rats with Parkinson's symptoms actually improved when they directed light to the thigh.
Wow.
And then they did that with later on transgenic mice with Alzheimer's disease.
So even though it was in the thigh, it was having a systemic effect.
Yeah.
Wow.
Yeah, I think they're funded now to do a study on what happens if you do a probe into the brain. They actually done it on animals and found that it seems to improve the markers in that area of the brain.
Wow.
So light does something. It does, where it's close to it, it helps a lot. Even though it's far away from it, it has this systemic effect. And they tried to explain it. At the time, some descriptions were used, like the abscopal effect, kind of like cancer when you treat one side, another side of the body respond.
Yep.
They call it circulating factors without knowing what it was. But it was just, I think, in 20, that there was a paper showing that there are lots of free-floating mitochondria in your body in the blood. So now we understand that
Wow.
photobiomodulation affects the mitochondria. Now, what if you have now circulating mitochondria all over your body?
Wow.
That kind of really, it just rung a bell, to many of us. That's it, that's one of the main explanations of why this seems to have has a systemic effect, because mitochondria is in your blood circulates through your system several times a minute, so it gets all over your body. And there was another study in Montreal where the mitochondria also gets deposited into various parts of the body where it is needed. So you put all these together, it kind of explains. From your nose, and the nose is good because the blood vessels, are close to the surface, the membrane. So capillaries are very close, pretty dense. Then this is where it gets, it gets
exposure
all throughout the whole body.
So when you stick it up your nose, so I'm going to demonstrate for those watching on video. Basically, you put it up your nose like this, and this is the 810. So there's the blood in the body is going past this area here, isn't it? So it's actually those light waves are hitting your entire blood supply through the intranasal delivery mechanism. Is that right?
Yeah, the nasal area is actually one of the areas where there's more blood capillaries per square centimeter than most part of your body. And it's necessary because it controls the moisture level in your, and that you get processed very quickly. Now, I'm involved in quite a lot of research on its effect on the brain, and that's quite important. When we use the 810 nanometers in your infrared, it penetrates deeper.
Yep.
That certainly hits the olfactory bulb, and the olfactory bulb is obviously part of your brain, and there's a direct channel to the memory area, like hippocampus.
The hippocampus, yep.
Yeah. And then we've noticed improvements in memory function. So that led us to, later develop all these other things and do a clinical trial on Alzheimer's disease, which we're doing now. It also, there's a direct channel to the thalamus, which is thalamus does this. It receives signals from other parts of your body and distributes to different parts of your brain to process it. So that the olfactory is very important. When you have certain neurological conditions, Alzheimer's, Parkinson's, a number of other things, you lose the sense of smell.
Wow.
Early, before even other senses.
So when I'm putting the vLight up my nose there, the 810, that is stimulating the mitochondria in the blood that's passing that area in the brain, but also penetrating deeper into the hippocampus and to the thalamus.
Yeah. So to be technical, the direct channel is to the entorhinal cortex, which is like the gateway to the hippocampus.
Wow.
So they're kind of all part of the whole system.
You've already had a number of trials done in the past in different areas. What has it been shown in those trials? What have you managed to sort of show that photobiomodulation does in delivering it through these mechanisms?
Before I saw that, the interesting thing about photobiomodulation is, and this, I guess it relates to functional medicine, where you try to address this whole problem at its most fundamental basic level, which is the cell, the mitochondria.
Yes.
Mitochondria is everywhere. All the energy comes from there, and a lot of other things happening. So I guess if you can tackle it at a very basic fundamental level, then these other symptoms and markers that come many levels above can, hopefully you will try to resolve that.
That makes so much sense. That makes so much sense to me. Yeah, absolutely.
And so so for this particular demographics we're doing, like I mentioned, moderate to severe, and they are pretty far advanced. Almost all of them will require the involvement of caregivers because they're not independent. And so we have a battery of tests that particularly apply to them, the most severe cases. In our earlier case reports, we used tests for cognitive ADAS-COG, Alzheimer's disease assessment scale for cognition. We use MMSE, mini mental state exam. We have, these are amazing. Then we have clinical, observations and reports. And so we found that we did one, we started seriously studying Alzheimer's patients and dementia patients in 2015. And we published this in 2017. This is a small number of cases with the neuro you saw, it pulses at 10 hertz, 10 times a second. And that is, we do it because it used the data from an animal study done at Harvard and Massachusetts General by Michael Hamlin's lab. Shows that the animal recovering more quickly from brain injury.
Wow.
So we use 10 hertz, but he hasn't explored a whole range of frequencies. So use that, it seems to help in these small studies. And then University of California, San Francisco, Professor Linda Chow did a completely independent study. She wanted to replicate what we did, and I said, okay, use 40 hertz, because 40 hertz, in 2016, there were a lot of publications, is to do, it shows that 40 hertz is a gamma, this is associated with, it's what you find when your hippocampus is trying to encode memory. So it shows 40 hertz.
Okay.
40 hertz helps with memory encoding. It helps to reduce the excitotoxicity in the brain when you're encoding memory and stuff like that. And then MIT published a very important study towards the end of 2016. They showed that when light put animal in a cage, the rodents in the cage, you pulse light just at 40 times a second, 40 hertz, the markers, the beta amyloid counts in the brain reduce significantly.
I've heard of that. I've heard of that study. Yeah. And they've been using it.
Behavior.
Yep.
Right. So we thought, okay, they are still doing this. They're still doing studies. They're trying to do human studies. And what they found was the markers in the visual cortex reduced drastically, but not anywhere else, not even the hippocampus. And I reckon that's because when the animals in the cage, at 40 hertz, it was processed through the eyes, goes to the visual cortex, and then the markers reduce significantly. Or for me, photobiomodulation, what we do is we direct light with near-infrared light so it can penetrate. And we target at the default mode network, which is closely associated also with Alzheimer's disease. So I did a case, I did a single case, and it wasn't published. It was presented in the Alzheimer's conference. But Linda Chow did that on 8 patients.
Wow.
And then they improved, over 12 weeks. And she also found that, so she's also a professor of radiology at UCSF. So she used the MRI scan, fMRI, found that actually after 12 weeks, the function of the brain actually measured through fMRI improved as well.
Wow.
They improved in the default mode network.
Yeah.
So here she did an independent study. The subjects, she used the similar scale, ADAS-COG, and she did use MRI and found that even through imaging, it confirmed the
changes.
That's fantastic because, you can argue about whether it should be a placebo study and all that, but imaging is imaging.
Exactly. You can't argue with it. Yeah, exactly. Yeah.
I thought that was great.
So she's using the 40 hertz. Is it delivered through your device or through the intranasal and transcranial? Yeah. So it's not like with the rat study where it's actually just in the room, so to speak.
Right.
It's actually getting in to so that makes a whole lot of sense. And so improved function over a 12-week period is a pretty short period of time. I wonder what would happen if you did that for a year. With
the one thing about this in Alzheimer's disease is, Alzheimer's disease is neurodegenerative. So the person will just keep declining and they decline because of the genome, the function of the genes. There's not much you can do until you can maybe edit the genes or something like that. You can change the gene in some way. Users of our device will really have to use it forever. For the rest of their lives, because this is to stop the degeneration. But the good thing is our devices are home use. Yeah,
they're easy to use. Yeah.
Now I have to say that these studies are just a few subjects. It's very easily dismissed with so we reserve our judgments or claim until we've done the full study. So that's
thing is, yeah, but the thing is, Dr. Lew, if you have a loved one who has Alzheimer's now, and you have and this is my approach with my mum, I can wait 10 years, 20 years for various clinical studies to prove that, say, hyperbaric works, or photobiomodulation works, or, these things, but these are pretty low risk interventions. So my argument is, well, if it's my loved one, I'm definitely trying it. Like, I want to use it, even if these studies are preliminary studies and they're not yet fully accepted by the scientific community. There's a value for the person listening to this recording who wants to do something proactive now, who has a loved one who's suffering from something like this, to try. And if we wait forever until all of the clinical trials for everything is done, we all have to weigh up our own risk-reward scenario.